Hello. This is the second video on integration by parts, which is a very important Math 112 Calculus 2 topic. In this video, we're going to be going over two more examples on integration by parts. So we're going to start our first example by modifying the problem we had in our previous video, which was the integral of x times e to the x. And we're going to change it up by making it first a definite integral, and then we are also going to square the x term, which is going to change things a little bit. So let's get into it. We're going to first make our choice of u, because we are working on this side with our u dv. We are going to make u x squared, and we are going to choose du to be 2x. Just like the last video, we're going to take dv to be e to the x, and then v to be e to the x as well, because the integral is the same. So I'm going to notate this a little bit differently, because when I do integration by parts with definite integrals, I like to save it all till the end. But sometimes you'll see people do the definite integral parts at the very beginning, but I do not like to do that, so I'm just going to do the integration out first. So we end up with u times v, x squared e to the x minus du times v, which is 2x e to the x dx. Now, if you watched the last video, you know that, and let's actually pull this constant 2 out. So we can actually bring the 2 out to over here, and we now have the integral of x e to the x, which, as we found out before, we can't solve normally. And this is also from 0 to 1, and I'll actually evaluate this at 0 to 1, because it's definite integral. But to solve this, we need to do integration by parts again. So this is just an example to show us that sometimes one integration by part isn't enough, and we actually need to do it more than once, maybe even 3 times. That's happened before. Sometimes you'll have to do it a lot of times. So in this case, we have to do it a second time. So we're going to, just like the last one, we're going to choose the same u and du and v and dv equals e to the x. So I'm going to bring it down. So we start with x squared e to the x minus 2 times u times v, x e to the x, du times v minus the integral of e to the x times 1 dx. This is evaluated, the full thing is evaluated from 0 to 1. This is also evaluated from 0 to 1. And then, of course, we can just take this integral, it's just e to the x, and then if we distribute everything out, we end up with the integral, I'm going to put it in brackets, x squared e to the x minus 2x e to the x. This integral is just e to the x, and there's a minus sign right there. So this becomes plus 2 e to the x. And then the entire thing is evaluated from 0 to 1. So here's our integral. This is our indefinite integral. There would be a plus c, but since we're doing a definite version, we can leave out the plus c. And now to do the actual definite part, we plug in the values of the limits at both endpoints and just subtract them, just as if it was a normal definite integral. So we're going to take 1x squared, so I'll write it all out. 1 squared e to the 1 minus 2 times 1 times e to the 1 plus 2 times e to the 1. That's our upper bound. And then minus 0 squared e to the 0 minus 2 times 0 times e to the 0 plus 2 e to the 0. And then this is e. This is just e minus 2e plus 2e. So this cancels out, and we just get e on the upper side. And then this is 0, this is 0. And then right here, we end up with 2e. So after all that, we then subtract. Oh wait, this is not 2e, my bad. E to the 0 is just 1. Oops, gonna erase that. After all that, we end up with our integral. This upper side just becomes e, and then this lower side just becomes minus 2. And thus, our integral is e minus 2. So it was a bit of work, but definitely not so bad. You know, it's just, once you get into the grind, you can totally figure it out. All right, I'm just going to erase the board, and then we'll get on to the next example. Okay, so we're going to do our last example, which is a tricky one, but if you're a little clever, you can figure out a good way to go about it using integration by parts. So we want to find the integral of ln of x. This is an elementary function. We see this all the time. We'd like to know what its integral is. Its derivative is pretty easy. So what's the integral? Well, there's no good way to just integrate this out normally. And if you're looking at this and want to apply integration by parts, you'd think, well, we need two functions to be multiplied together in order to use integration by parts. And you're right, we do need two functions to be multiplied together. But here's the clever little trick that you can use. ln of x, I hope you like my cursive ln of x right here, is also equal to ln of x times 1. And 1 is a function. It doesn't change anything. It's the same thing. So what we can do is we can write this little 1 here, 1 times ln of x. And now what we do is using this function here, which is just the constant 1, and this function ln of x, we can apply integration by parts. So which one do we choose as our u and which one do we choose as our v? Well, the whole problem in the first place was, what is the integral of ln of x? So we don't want to choose that as our v, because it doesn't have an easy integral. So what we want to do is instead, let's say u is equal to ln of x. That means our du is equal to 1 over x. And that means our dv is 1, and our v is x. Now you might be a little confused, like, where is this going? Well, we get this really nice thing happen. So first we get our uv, x times ln of x. And then when we do our integral, look what happens. Minus the integral of x times 1 over x dx. And this just cancels out to become 1. So now we just have the integral of 1, which means that our integral is equal to x ln of x minus the integral of 1, which is just x, minus x plus c. And that's a really cool result. And let's just verify it. Let's take the derivative of this. So if we take the derivative of this, it's the derivative of this bit, which we use the product rule. So that's going to be derivative of this times this. So that's ln of x plus the derivative of this, so x times 1 over x, minus the derivative of that, so minus 1. This is just 1. So ln of x plus 1 minus 1, that's just equal to ln of x. So, look, we've just proved our integral using integration by parts. So there's a lot of clever things, clever and cool things that you can do with it that just come from this really simple formula that comes from the product rule. Hopefully this video has been helpful. Let us know if there's anything else that you want to see in our next video tutorial. Again, thank you to the Institute for Teaching Excellence for letting us use the whiteboard. And if you want to come to Math Club, just send an email to me, wjm9 at njit.edu. Thanks for watching.